All right, so we're going to start looking on page 2 of your packet. I'm going to be doing number 1, but before I do that, I want to look at the rules for critical points and maxes and mins. Now, this is review for you. I'd like you to just take a couple minutes, maybe pause me, and just look over all of this stuff that we have up here. Okay, so take a minute, pause me, read it over. Okay, so if you look at number 1, it's asking you to find out when the function's increasing, decreasing, finding maximums and minimums, and obviously all of this is without a calculator. So the first thing we want to start with is we want to start by finding critical points. Now, critical points occur in 3 places. At the endpoints of an interval. Well, an interval would mean like we have, something in parentheses over here, like between 2 and 10. We haven't gotten that far yet, so for right now, we're going to discount that. The second is where the derivative will equal 0. That's the one that we're going to focus in on, and I'll show you how. And then number 3 is where the derivative doesn't exist. In order for the derivative to not exist, we would have to have a fraction. And we don't have a fraction here, so we're not going to be dealing with that one yet either. So we're just going to start by taking the derivative, and we're going to set it equal to 0. So if I take the derivative of f, I get f prime equals, and that's going to be 30 x to the 4th minus 150 x squared. Okay, now we want to take this, we want to set it equal to 0 because that's going to help us determine critical points. So I noticed that both of those terms have a common factor of 30x squared, so I'm going to take that out, and that's going to leave me with x squared minus 5. Okay, so if you remember your good old Algebra 1 days, we can make a little t-chart here. And my left factor is going to be x equals 0. And on the right here, I have x equals plus or minus, because remember, we're going to be taking a square root of radical 5, so we always need the positive and the negative value. So x equals plus or minus 5, radical 5, and x equals 0. Those are our critical points. Okay, then what you learned last year was you had to do a sign chart. So I'm going to do a sign chart for the derivative, so we always label that f prime. And what you do is you put your 3 critical points on there, obviously in numerical order. So we have negative radical 5, then 0, then radical 5. And if you recall from last year, what you're trying to do is you're trying to figure out what sign values you have here. So do I have positives or negatives? Okay, so this is the way I do it. Let's work from left to right, so over here. So I'm trying to pick a number that's less than negative radical 5. Well, we don't know exactly what radical 5 is, but we do know it's a little bit more than radical 4. So if radical 4 is 2, then I know that this would have to be like 2 point something or other, but it's negative. So I'm going to start by plugging in like a negative 3. So what I do is this is a sign chart for the derivative. So I'm going to plug in negative 3 into the derivative and just see if I get a positive or a negative answer. That's all I'm looking for. Okay, so I'm going to go right over here, and I'll just show you my work for the first one. So I'm going to plug in 30, then I'm putting in a negative 3, squaring that, times negative 3, squaring that, minus 5. Now guys, what you get doesn't matter as much as what the value is, and I don't think I'm saying that correctly, so I'm going to repeat it. I just want to know whether this times this gives me a positive number or a negative number. That's all I really care about. I don't care what that actual number is. Okay, so I know in here I'm going to get a positive number. And then I know in here, when I square that negative 3, that becomes positive 9 minus 5, which is also a positive number. So I know a positive times a positive is a positive. So then that means when I plugged in negative 3, I got a positive number. Okay? Now, I'm going to do the same thing, but now I'm not going to show the work, and I am going to pick a number right in here, like negative 1. So if I put a negative 1 in here and I square that negative 1, don't you see that this will be positive? And then when I plug in -1 here and square it, I get 1, right? But 1 minus 5 is -4. So I had a positive times a negative, which means that would be a negative here, right? Okay, so I'm going to put a negative there. All right, I'm going to do the same thing again. So now I'm in this interval. I'm going to pick +1 because it's easy. Well, a +1 here would give me a positive, and a +1 when I put it in here is 1, but -5 is negative. So positive times a negative is a negative. Okay, and then I repeat it one more time for out here. So I'm going to do +3 here. Okay, you could do +4 or +5, it really doesn't matter, but I'm going to do +3. Well, a oops, thought I had my pointer on there. A +3 in here will give me a positive answer, right? Now, 3 squared is 9, minus 5 is also positive. So I've got a positive times a positive, which is a positive, and there's your sign chart. Okay, so what this tells us is the derivative is positive here, which means the function's increasing. What this tells us is in this interval, the derivative is negative, which means the function's decreasing. And lastly, since the derivative is positive here, that means that the function is increasing. Okay, and I'm just getting all of that right from in here. So part A is saying find all the values of x for which the function is increasing. Okay, so increasing would be where the derivative is positive, right? So then for part A, you could say from -infinity to -5, okay, or from (5) to infinity. Okay, that would be where the function is increasing because the derivative is positive. We will get into sentences and all of that tomorrow, so let's just worry about getting the intervals set. All right, let's go to part B. So then, where is the function decreasing? That would be between (5) and +5, because that's where the derivative is negative. That would mean the function's decreasing. Okay? Okay, now part C and D want to know what value of x would we have a maximum and what value of x would we have a minimum. So here's my sign chart again. So now this here, so again, let's just repeat. The derivative is positive here, which means the function is increasing. Then here, the derivative is negative, which means the function is decreasing. So my little green pointer arrow right now is going to sketch in the air a picture of what the function would look like. Okay, so we go increasing, increasing. Then once I hit here, I start decreasing, which means right here I have a maximum. So when our derivative goes from positive to negative, about a certain point, that point is a maximum. So there's a maximum. So we have a maximum at x equals -5. Okay? And I'm going to repeat myself again. So listen, we have a maximum at x equals -5 because the derivative changes from positive to negative about that point. I know you've written sentences like that before. Because if the derivative changes from positive to negative about that point, that means the function increases, then decreases, which would form a max. So a minimum would be the opposite, right? Because here, the derivative is negative, then it changes to positive, which means the function is decreasing, then at here, it changes to increasing. Decreasing to increasing would make a minimum. Okay? All right, so then we have a minimum at x equals (5). You should be taking notes on page 2, okay, in your packet. And again, I have a minimum at x equals radical 5 because the derivative changes from negative to positive about that point. Okay, and here would be the sentence. So we have a minimum at x equals radical 5 because the derivative changes from negative to positive about that point. Okay, and we'll get more into the sentence writing in the next class, but I just wanted to give you an example of what your sentence would look like. And up here I would have the same exact sentence, except I would have, because the derivative changes from positive to negative about that point. Okay, all the sentences tend to be the same every single time.